Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to wrap up our chapter on getting started with containers. Before we dive in, I'd like to remind our amazing listeners to rate our podcast on whatever platform you're listening to us. Your feedback means the world to us.
Absolutely, Sheila. We're excited to summarize what we've learned about containers and their significance in the Kubernetes ecosystem. But first, let's kick things off with a quiz question for our listeners.
Great idea, Victor. Here's the question for our listeners. What key benefit do containers provide that traditional virtual machines don't? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of why containers have become so popular. I'm curious to see how our listeners will approach this. There are quite a few angles to consider when comparing containers to virtual machines.
Indeed, Victor. Now let's start our summary by refreshing our understanding of containers. Can you give us a quick overview?
Certainly, containers are lightweight, standalone packages that include everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. They provide consistency across different environments, from development to production.
That's a great explanation. I've heard containers compared to shipping containers. Could you elaborate on that analogy?
Absolutely. Just like shipping containers standardized global trade by providing a uniform way to transport goods, software containers standardize software deployment. They encapsulate the application and its dependencies, making it easy to move between different environments without worrying about compatibility issues.
That makes a lot of sense. Now, we spent quite a bit of time discussing Docker in this chapter. Could you summarize why Docker is so important in the container ecosystem?
Of course, Docker popularized the use of containers by providing a user-friendly platform for building, shipping, and running containers. It introduced the Docker file for defining container images, a powerful command line interface for managing containers, and Docker Hub for sharing container images. While there are other container systems, Docker remains one of the most widely used.
I see. So, if I understand correctly, Docker made containers accessible to a wider audience of developers and operations teams. Is that right?
Exactly, Sheila. Docker simplified the process of working with containers, making it easier for teams to adopt containerization. This ease of use was a key factor in the rapid adoption of containers across the industry.
Got it. We also talked about container images and registries. Could you remind our listeners why these concepts are important?
Certainly. Container images are the blueprints for containers. They're read-only templates that contain a set of instructions for creating a container that can run on the container system. Registries, on the other hand, are repositories for storing and sharing these container images. They play a crucial role in the container ecosystem by allowing teams to version, distribute, and deploy their containerized applications efficiently.
That's really helpful, Victor. I'm curious, what are some best practices when it comes to working with container images?
Great question. Some key best practices include: Point 1. Keeping images small and focused on a single application or service. Point 2. Using multi-stage builds to minimize image size. Point 3. Regularly updating base images to patch security vulnerabilities. Point 4. Tagging images with specific versions rather than using the latest tag in production. Point 5. Implementing image scanning to detect security vulnerabilities.
Those are excellent tips, Victor. Now, I'm wondering about real-world implementations. How are companies using containers in production environments?
Many companies are leveraging containers for microservices architectures, which is a way of building applications as a collection of small independent services, continuous integration and deployment pipelines, and to ensure consistency across development, testing, and production environments. For example, companies like Netflix, Uber, and PayPal use containers to deploy and scale their services efficiently.
That's fascinating. It really shows the impact containers have had on modern software development and deployment. Before we wrap up, do you have any fun facts about containers to share with our listeners?
Actually, I do. Did you know that the Docker logo, which features a whale carrying shipping containers, is named Moby Dock? It's a playful nod to both the shipping container analogy and the classic novel Moby Dick.
That's hilarious and clever. Speaking of clever things, let's circle back to our quiz question from earlier.
Great transition, Sheila. Yes, let's reveal the answer to our quiz question.
The key benefit that containers provide over traditional virtual machines is their lightweight nature and faster startup times. Containers share the host system's kernel, making them more efficient in terms of system resources and allowing for near-instantaneous startup.
Excellent summary, Sheila. To wrap up this chapter, remember that containers are a game-changing technology that provides consistency, efficiency, and portability for applications. They're a fundamental building block for modern cloud-native applications and are essential for understanding Kubernetes.
Thank you, Victor, for this insightful summary. To our listeners, we hope you found this chapter on containers informative and engaging. As always, we'd love to hear from you. Please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy containerizing.